sometimes when we're using elimination to solve these systems of equations, our variables do not cancel out. If we look at this equation, my x's, I have a 3x and a negative 2x. So those two aren't going to cancel out. And my y's, I have a positive 4y and a negative 5y. So those aren't going to cancel out either. So then I have to kind of get a little creative in order to get them to cancel out. And in this case, we're just going to look at the x's. So I've got a 3x and I have a negative 2x. And I have to think to myself, what number could I make 3 and could I make negative 2 by multiplying them by a certain number so that they'll cancel out. And if we look at it, the easiest thing you could do is always just multiply them together. 3 times 2 is going to give me a 6. So I know I can make each of those coefficients a 6. So that's exactly what I'm going to do. Up top to my top equation, if I want 3x to become a 6x, I multiply it by 2. And I'm multiplying the entire equation by 2. So I've got 6x plus 8y equals negative 2. And now I'm going to do the same thing for the bottom, except I'm going to multiply it by a 3. So I'm going to have negative 6x minus 15y equals 30. Now, once I get it to this point, I can see that my coefficients do cancel out. Now, if both numbers would have been a positive, I can multiply one of them by a negative number. That way I know that they're going to cancel out. So now I can combine these two equations to eliminate my x's. 6x plus negative 6x is going to give me 0x, which is going to eliminate my x factors. Positive 8 plus negative 15 is going to give me a negative 7y. And negative 2 plus 30 gives me a 28. Now I've got a single variable, single equation, divide by negative 7, divide by negative 7, and I'm going to get that y is equal to negative 4. So half my problem's done. I've solved for one of my variables. Now I have to go back into my original system of equations, take one of those equations and plug in y equals negative 4. So we'll do that with the bottom one. We're going to use negative 2x minus 5 times y, and we just saw that y is equal to a negative 4, and that whole thing should be equal to a 10, so I'm going to plug in negative 4 right here for y. Now I can go about solving this. I have one equation with one variable. I can solve for x. First thing I gotta do, negative 5 times negative 4 gives me a positive 20. And then everything else stays the same. I didn't change my x's. I didn't change my right side of the equation. To get my negative 2x alone, I have to subtract 20 on both sides. So I've got negative 2x equals negative 10. Finish off this problem. Get x alone, I divide by a negative 2. So I'll get x equals a positive 5. Now if I look at this, I see that y is negative 4. X is 5, so I can write this solution in terms of a point. 5, comma, negative 4. Remember, x comes first. Y is second. And if I would graph these two equations using Desmos, I can see that they're going to intersect at the point 5, negative 4.